Hello, this is the luckiest maths teacher in the world. Thank you so much for watching. We go today through equations with brackets. So before we get to that, just let's look at an equation like this. 2x plus 6 equals, let's say, 48. So in this, the way I would solve that, I could subtract 6 from both sides. So then 6's cancel out. I'm left with 2x equals 48 minus 6 is 42. And then to undo timesing by 2, I divide by 2. Okay, and I get x equals 21. So I haven't taught you anything new yet. You've been doing that for ages. But let's add something like this. 2 times x plus 6 equals 48. So this is a totally different equation. The only way this differs from this is the order of operations, and that's what brackets do. They change the order of operations. So when we have brackets like this, we need to undo things in a different order, and that will result in a different answer. So what this means here is that I've added 6 to x first and then times by 2. Over here, I times by 2, then added 6. So if I want to undo everything that's been done to x, because the last thing I did here was times by 2, the first thing I need to do is divide each side by 2. I need to undo the multiplication. So then I get x plus 6 equals 48 divided by 2. Subtract 6 from both sides, because I want to undo adding 6, and then x just equals 18. Okay, so I got a different answer in both cases, and I would expect that, because the order of operations does change things. So that's what brackets mean. They change the order of operations. Now, I can, again, check my answers by substituting my answer into the original equation. So if I change x to 18, I get this. So that's the same as 2 times, because I've got to do the addition first, 2 times 24, and that does equal 48. So I know my solution is correct, because I've substituted and checked. Okay? So, equations with brackets, you just change the order of operations. And you can still use flowchart method, or you can use the balance method. Let's look at another example. So let's say we have an equation 3 times 2x minus 5 equals 60. Okay, so I can use the flowchart method if I want. So what I've done is I've started with x, and I need to get everything in the brackets done first. So I apply my normal BODMAS to what's inside the bracket. So what I've done to x is I've times by 2 to get 2x. Then I've subtracted 5, and that's how I got what's in the brackets, 2x minus 5. Then what I did was I took my answer and I multiplied by 3, and I ended up with 60. So that's how I ended up with 3 times 2x minus 5. So to solve it, I start with my answer 60. Instead of timesing by 3, I divide by 3. Instead of subtracting 5, I add 5. So I get 25. And instead of timesing by 2, I divide by 2. And 25 divided by 2 is 12.5. So the answer here is x equals 12.5. So again, I can check it. So I take my equation and I substitute x is 12.5. So if I do that, I have to do the brackets first. So 12.5 times 2 is 25. So I get 3 times 25 minus 5. I then do the subtraction. 25 minus 5 is 20. So I have 3 times 20. And that does equal 60. So I know I have done the right thing. So I'm just going to show you one more type of example where you have to expand the brackets. So let's have a look at this equation here. Now this is different. I have no choice here but to expand the brackets using the distributive law. The reason is because I actually have the letter, the pronumeral, in 2 different spots. The problem with that is I don't really know how to solve equations like this. I need x, or whatever the letter is, to be in one spot. I have to first get it into one spot. So I have to expand the brackets in this case. So hopefully you remember the distributive law is you take the thing out of the brackets, you distribute it to everything inside the brackets by multiplication. So I go 2 times x, 2 times 6, And of course, 2 times 6 is positive 12, because they're both positive. And then I've still got my 3x there, which equals 9. Now I collect like terms. So these two are like terms, 2x and 3x. I can't add 2x and 12 together because this term here doesn't have an x. It's not a like term, so I leave it alone. So 2x plus 3x gives me 5x plus 12 equals 9. Okay? So now this is exactly like equations you've solved a million times. It didn't start out like this. I had to expand the brackets only so I could get x in one spot. But now that I've got that, I do it the usual way. So you can use balance method or flowchart, whatever you want. For this, I'll just use the balance method. So first I undo it by subtracting 12 from each side. So I get 5x, 12 minus 12 cancels out. So 9 minus 12 is negative 3, and there's nothing wrong with having negatives. I need to now divide each side by 5. So I get x is negative 3/5 or negative 0.6. So again, I can check my solution by substituting this into my original equation. And I can use my calculator to do this as well. So I have 2x plus 6 plus 3 lots of x. So that equals, so I do the brackets first. So negative 3 over 5 plus 6 equals 5.4. And then 3 times negative 3 over 5 is negative 1.8. So that's just 10.8 minus 1.8, which does equal 9. I can be sure my solution is correct. So you only need to expand the brackets when x is in more than one spot. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.